Welcome to Section 4, Data Storage on AWS with Terraform, S3 and DynamoDB. In this section, we'll discover S3, the object storage with buckets and objects like actual files on AWS, and DynamoDB for NoSQL database for items at any scale. Before we go into the details of implementing S3 and specific things like bucket policies, versioning, uploading, and everything about S3, let's take a look at what is S3 and how it works. S3 is a durable, highly scalable, secure object-level storage. So the objects that we're talking about here are text files, PDF files, any of the objects that you can imagine, the files stored on your computer, for example. S3 builds on simple object and bucket concepts, and these are the two fundamental pieces about S3. You create a bucket, and then you upload your objects and read them, write them, define lifecycle rules on them, define access rules on them, and so on. You can store and retrieve unlimited amount of data with S3. There is no limit on that. And S3 is accessible via AWS console and several different tools and languages. You can even implement your own API with languages like Python or Java. And AWS S3 integrates well with most of the AWS services. And that's one of the most beautiful pieces about S3. You can easily implement object lifecycles and events regarding changes in S3 objects and buckets. S3 has various pricing models, and it's adjustable depending on your storage needs of the objects. You can choose frequent access or infrequent access, and you can even store in the cold storage and keep them there for several years. And implementing S3 with Terraform is simple and very easy, as you've seen with our previous example, but we'll go much deeper than that. And talking about the basic concepts of S3, again, object and bucket are the key elements of S3, as you can see in this diagram depicted. And the bucket is a fundamental object in S3. It stores files of any type, even the files with custom types that you create. Buckets are global, but it has to reside in a region. And one thing really important about S3 is S3 buckets use the naming convention as DNS names. So the bucket names has to be unique globally, not just in your account or in your region. It has to be unique everywhere. You can define granular access to your buckets and objects with policies. You can scale S3 buckets to your needs, and you don't even have to flip a switch about that. AWS S3 takes care of all the scaling and all the high performance needs for your application. And finally, creating buckets are free. The operations inside them are not. On the other hand, objects are basically what's stored inside a bucket, the files that you store inside your bucket. And those files can be of any type. And S3 not only stores the file itself, not only the bytes of the file itself, but also the metadata about the file, like the file type, creation date, modification date, and so on. 5 terabyte is the maximum limit for a single file. And also, single upload can be up to 5 gigabytes. And if you have a file bigger than 5 gigabytes, you have to split it into different pieces, and S3 can combine them, merge them together once you finish uploading. What makes up the cost for S3 is basically storage, read, write, and everything that you operate on your bucket objects. Now let's talk about the storage classes in S3. S3 basically has 5 different storage classes. First one is standard and standard infrequent access, one zone infrequent access. And we have RRS, and we have finally Glacier, which is the cold storage. So let's start with the standard model. Standard model is basically the frequent data access, and low latency is critical. So let's consider that you're hosting a website with S3, and that is going to be the standard model, which that you need to access your files in terms of CSS, HTML, JavaScript, and so on. All your static files that needs to be accessed in the standard storage class. On the other hand, in the standard infrequent access, low latency is also important like the standard model, and it is cheaper than the standard model. Data is infrequently accessed, and retrieval fees might apply to your objects. Next up is one-zone infrequent access. One-zone infrequent access also provides low latency. There is no redundancy for your data, like the other models, and again, retrieval fees may apply. The RRS model is for non-critical data, like the reports from last year or logs from your application in past 90 days. And with the RRS model, the data is easy to reproduce for AWS, so you can get it back easily. And finally, the Glacier is the cold storage for S3. It is basically for the long-term data archival purposes, and retrieval requires at least 5 to 6 hours minimum. And is the cheapest storage solution because it doesn't really cost AWS anything. It is stored in the magnetic disks and basically for the files that you don't even need to access for a very long time period. Let's look at the details of these storage classes more. Durability for the standard model is 99.9 times 9, so it's highly durable for the standard model, standard storage class. And the availability for that is 99.99. So it's highly available again for the standard model. And the latency is in milliseconds term for the first byte that you receive while reading that object. And SSL support is available, and you can manage your objects with the lifecycle policies in the standard class. Standard infrequent access class is almost identical to the standard model. It has the same durability. In terms of availability, the standard infrequent access model provides 99.9 availability. So it's less available compared to the standard model, but it's still so highly available. And the first byte latency is also in milliseconds. SSL support is available, and you can manage the lifecycle of your object with lifecycle policies. One-zone infrequent access class is the same durability with standard and standard infrequent access, and the availability a little bit less than the standard infrequent access, which is 99.5. And you have the millisecond latency for the first byte that you read. You have the SSL support, and you can manage the lifecycle of your objects with lifecycle policies. RRS is a less of a durable storage type. You have 99.99 durability with RRS, which is the lowest one in the classes. And the availability is the same with standard class, which is 99.99. And the first byte latency is in milliseconds again, and you have SSL support, and you can manage the lifecycle of your object with lifecycle policies. The last one is the Glacier class, which has 99.9 times 9 for the durability, which is exactly the same as standard infrequent access, and one-zone infrequent access. And the availability of the objects with Glacier class is the same as the standard model, which is 99.99, which is highly available. And the first byte latency is minutes to hours, depending on the size and the time that passed since you stored that object in Glacier. And you have the SSL support, and also you can manage your lifecycle with management policies. And let's talk more about these lifecycle policies because these are important pieces in S3 object lifecycle. So you start with S3 standard in your most operations. And let's assume that you're storing your application logs. And after 30 days, you don't really need them to access every single day, so you change your storage class with a lifecycle transition. And you use the infrequent access model, which is costing much less than the standard model. And after 60 days passed, you move on to Glacier, for example, to keep your costs low. And that really helps because Amazon Glacier is literally the cheapest solution in S3 for the objects that you don't frequently access and don't really need anymore. And you can even define your exploration actions after several years, like 3 years maybe. And talking about the S3 security, it can be achieved in several different ways. The first up is IAM. You can restrict access to buckets, objects for IAM users, groups, and roles. And bucket policy is another way to achieve that, and you can specify your own restrictions on buckets and objects using JSON policies. And access control lists, or ACLs, you can grant read-write access to buckets for other AWS accounts. So you can basically give access to another account, completely different AWS account, to read or access your buckets privately. And more about the S3, we have the cross-region replication for extra redundancy and compliance. If you enable cross-region replication, your objects in the bucket replicated to another region for high availability and redundancy. And you can even do that for compliance reasons to comply with the law or regulation. Access logging is available for S3 buckets and objects for audit and monitoring purposes. You can have events and notifications for detailed monitoring of actions happening inside your S3 buckets and objects. You can use versioning for objects to maintain different versions of the things, and you can use that for the purposes of disaster recovery. And you can have encryption at rest and at transit for extra layers of security, which is highly beneficial for sensitive data that you store in S3. MFA protection is also available if you enable it for object deletion. So if you enable that, in order to delete an object or a bucket, you have to use MFA codes to do that, which adds extra security and extra assurance. Again, the bucket names are globally unique, which works similar to DNS. So it's not only unique in your account or in your region, it's unique globally. And another great benefit of S3 is the static website hosting. You can put your HTML, CSS, and JavaScript resources, and you can host your websites through S3, which is highly available and scalable.